Okay, so hi everyone. My name is Gal and I'll introduce myself in just a bit. But again, if any of you want to open your cameras or unmute yourself or ask anything, feel free to do it throughout the entire workshop. If you want to write a funny comment in the chat, that will also be very, very appropriate. Feel free to have fun because we'll be together for the next couple of hours. Okay, so today we're going to talk a bit about what is observability and how we can get observability in our modern Node.js applications. And then we're going to talk a bit about what are modern applications and about Node.js. Well, we're not going to talk about that much because you already know you've been to a two-day conference, but we're going to specifically talk about observability and how it can be challenging in those modern distributed applications. But before we talk about any of that, let me just quickly introduce myself. So I'm Gal, and I'm the Director of Engineering at Epsagon, which is a company that specializes in observability in modern application, distributed applications, the things that you would normally call Cloud 2.0 or Cloud 3.0, serverless, containers, Kubernetes. If it has more than a bunch of few services talking to each other, we are the solution for it, and we'll show you that a bit later on in the workshop. But this is what I'm doing today. I've been with Epsagon for the last 3 years, started out as an engineer, then led a team for a short while. Now I'm running the entire engineering department. Before that, I did some cool cybersecurity stuff at the Israeli Defense Forces, a lot of reverse engineering, a lot of low level. We worked with weird devices and C code and buffers, very different than the cloud native world that I live in today. But I think it's a very solid background to whatever other programming job you want to have. And other than that, I live in Tel Aviv, which has amazing beaches that even if now with COVID, not a lot of people can attend them. It's still fun to just walk by and have a cool sunny breeze. So that's a little bit about me. And now let's talk about what we're going to be doing today. So first, we'll do a quick introduction very, very quickly because this workshop is all about building and not about talking. And we'll talk a bit about what observability is and what are distributed systems and why observability in distributed systems is relatively challenging. Then we're going to build an Express application, a very, very simple Express application, but an application that interacts with third-party services. And we're going to see why that can be challenging. Then we're going to deploy said application to AWS Lambda. Now, for those of you who are not familiar with AWS Lambda, AWS Lambda is a serverless compute platform that enables you to run applications very easily and get set up very, very quickly. It has a bunch of other advantages. It scales out of the box. You only pay for what you use. You pay by actual invocation and not just for idle servers. But this is not a lecture about, this is not a session about AWS Lambda, but that's the tool we'll be deploying our application. The environment will be deploying our application to. So it's a nice thing you can learn on the way if you're not already familiar with it. Then we'll be tracing the application with Epsagon, and we're gonna talk about what tracing even means in a sec, but we're gonna see how we can understand what our application behaves like in production with Epsagon. And then at the end, we're gonna have a cool little live treasure hunt, which I hope will be fun for everyone. So let's get started quickly with the introduction. Karen, I think maybe you want to share the Discord link just one last time to make sure that everyone's in.
Sure, it's available in the, Daria already shared it. It's in the chat box, so please join us.
Do you think we need a poll to see if everyone's already in Discord, or we can just carry on?
Launched.
Okay, so that's the poll. So everyone join Discord, and if you have feel free. I'm also looking on this screen right here has the Discord, so feel free to join and ask any question along the way. If I want to be paying attention, Karen will yell at me, say, look at the Discord, and I will look at the Discord and answer your question or have a little conversation with you.
Okay, great. I see that everyone is joining us. Perfect.
Okay, so let's talk a bit about observability before we're going hard into coding. So the challenges that we're facing in our modern environments, and when I say modern environments, I'm specifically talking about environments that are built in the microservice architecture. Because even if you're running on Kubernetes, and even if you're running on ECS, and even if you're running on Lambda, you can just package your entire application into one deployment, deploy it all in the same place, and all of the challenges that I'm going to talk about today aren't going to be very relevant. But for most applications that are being built today, and for most applications that are transitioning to the cloud, we see a trend of moving from monolithic applications, which are these huge deployments that contains your entire application code that you have for every change to deploy the entire thing again, and there's one server running the entire logic, into microservices, where we have a bunch of different services, a bunch of different servers, each, let's say servers or Lambda functions or whatever, each responsible for a different functional logic functionality in the application. So let's look at an example. When I'm logging into Spotify and I want to listen to a song, and that's not a hidden commercial, you usually use Spotify and want to listen to songs, then there are a few things that I do. And in each of these steps, I interact with a different service. So when I sign in, for example, I'm probably talking with the authentication or the user management service, which signs me in and gives me a token with which I can authenticate to other services. Then I want to check out my homepage. So there's another service that is in charge of giving me my homepage and also building the recommendations behind it. And then I'm selecting a playlist, and the third service that is in charge of storing playlists and displaying them to the user is being invoked and returns the response. And then when I start streaming a song, there can be even more than one service that is in play, because there's one service that is in charge of starting the streaming, and it's probably asynchronously invoking another service that is in charge of the actual streaming of the song to my device to talk to me. So we've seen that throughout my interaction with Spotify, I'm talking with a bunch of different services. Each is in charge of a different aspect. And that's great for Spotify. We don't have to, it's really easy to sell the microservices architecture, because you can deploy each part separately and you can scale each part separately. And when something goes wrong in one microservice, it usually doesn't affect the rest of them. And there are a lot of selling points which caused a lot of people to move into this architecture. But the problem is that the traditional monitoring tools that we're used to use, let's say metrics and logging, in those old monolithic systems are not enough when we're looking on these new distributed systems. And the reason is exactly what I said before. We have a lot of moving parts that are talking to each other, either in a synchronous or an asynchronous manner. And it's hard to trace the actual request of the user through those different services. Because like the example I gave, when someone starts to play a song, and then there's one service that is in charge of actually queuing the start and is handing off another asynchronous message to a different service that is actually in charge of streaming the song to me. When the user is experiencing a problem, you have to start, it's hard to understand where is the root cause, which one of the two services is having problem. And that is a simple example. Think of a data pipeline that contains 3, 4, or 50 services. Then these problems can become really, really problematic. For example, Netflix has, I think, over 1 million microservices now. And just imagine what a request that is being made through Netflix, how it's being routed within their systems. But even if you're not Netflix, even if you're a regular company that has just 10, 50, or 100 microservices, that can still be quite challenging if you want to trace through these different requests. And you notice that I use the word trace because that's exactly the solution that the let's say the new movement, this new microservices movement found to this problem. And this is called this third pillar, or the third part of observability, that we're calling now tracing. And we're going to talk about it throughout the session today, or distributed tracing, is the act of saying, okay, this is a specific a scope in my code, let's say an API request. or an execution of a Lambda function, or making an API call to put an item in a database, or making an API call to read an item for a queue. Each of these operations can be scoped in a time frame and some additional tags on it and some additional metadata. And we can use these scopes with a combination of like a child-father relationship, where each scope is the child of a different scope, to see data actually flowing through our system. So we can see, for example, an HTTP request being made, one server is being triggered, is making another HTTP request, a second server is being triggered, putting an item into a queue, a third server reads the item from the queue, and we can correlate all of this flow throughout our application using the technology of distributed tracing. Now, this is not enough, of course. We still need metrics to be able to observe behaviors over time and spot bottlenecks, and we still need logging for rich context. Once we've found our problem, we still want all of these unstructured context that can help us. But tracing, we can use that as a gateway to easily understand our production environment and use tracing as a gateway to the other tools to explore our environment. So this is what we're going to be doing today. We're going to be building an Express application, and we're going to trace it. And we're going to show you Epsagon's unique take on tracing, which I like to call tracing on steroids, which basically give you extra visibility and extra ability to understand what's going on in your application. So I think we're good to go. We can just get started with actual coding. So before we start, everyone feel free to use any editor that you want. It doesn't really matter for the purpose of this workshop. I'll be using VI, but you can use really just anything you want. It doesn't matter at all. Make sure that you have Node and NPM installed. Karen will share the links to the installations now, because I realized that you can't click on these links via Zoom. But I guess you already have them installed because this is actually Node Congress. So I'd expect you would already try to hack some stuff on your own. But if you're not, feel free to install them now. Next, we're going to be creating a folder for the project. So I'm just going to do that right here so you can see what I'm doing. But I'll be actually making a directory called Node Congress and just going into it. So I'm in the directory now. And last but not least, all of the code that I'll be writing is available on a public repository. So you can use that as a reference throughout the workshop. So if you get stuck, if you're lost, first of all, feel free to ask me and feel free to ping us in the Discord chat, but also feel free to look at the code as a reference. I still would highly recommend you to code it on your own, because that's the easiest way to learn. But feel free to use the code as a reference, especially for the long URLs. So how about, Karen, we just launch a quick poll, making sure that everyone already has Node and NPM installed, and we can keep going. I see that everyone is prepared. Perfect.
Top-notch crowd.
Yeah. Okay, Karen, I think we can move on. Perfect. So next, just last thing before we actually start coding, let's talk about what we'll be building today. So our application is going to be a relatively simple Express application. Now, if you're not familiar with Express, but I hope that most of you are, but if you're not, Express is a server framework for Node.js, an HTTP server framework. You can easily create HTTP servers and HTTP applications with it. So it's relatively easy to set up, relatively easy to build simple application with, and that's what we'll be using today. We're going to build an application that gives a daily digest of a specific city. So if I'll ask for the daily digest of Chicago, I'll get the digest for Chicago. If I'll ask the daily digest for Paris, I'll get the digest for Paris, and et cetera, et cetera. And how it works is basically that our service will have an HTTP endpoint, a get HTTP endpoint. that accepts it's /digest/the city as a path parameter. And then our server will make three API calls in parallel. One to the weather API. That's an API that, given a city as a path parameter, returns JSON data on the weather in the city. Next, we can use the news API. Basically returns news of the that are related to the city. And again, the usage is basically making a GET request to this HTTP endpoint and giving the city as a path parameter. And the third one is the facts API, which is not related to a city, but just return a fun fact that is relevant for today. So you make a request giving a month and a day, and it will give you a fun fact. What day is it today? It's February 24th. So it'll give you a fun fact or not so fun about February 24th, depend on how your random generator likes you. So this is what we're building. We're going to be coding this part, and these parts are already set up. So these are APIs that you can actually use. Karen will share these APIs now. Karen, I see that you shared with the appendix of the city or the month of the day. Of course, when we code, we'll have to replace that with the actual city that we get here as a parameter. Okay, so let's get to coding. Cool. So first things first, when we're creating a new project, we're going to run npm init just so we have, and just one thing. Okay, just so we'll have an empty node project. So we're going to run npm init. And of course that we don't care about the licensing and everything else right now. So we'll just hit a bunch of enters. And now we have successfully initialized our node application, and we have a package.json file. Next, we're going to be installing our dependencies. Now, our project is going to have two dependencies. One, of course, is Express, since this is an Express application. The next dependency is going to be Got. Now, what is Got? Got is a relatively simple HTTP client, and we're going to be using this HTTP client in order to make the requests to the weather API, to the news API, and to the facts API. So I'm going to go ahead and install that, and you feel free to do that as well. And Karen, we can launch a poll to see that everyone has their project set up and installed the Express and Got dependencies.
Let's give it another minute because I see some people are not ready yet.
Yeah, no problem. NPM can take some time, or Yarn if you prefer it. But installing these dependencies can take some time when the internet's slow.
And we have a request from Alex. If you can please zoom in your screen.
Yes, let's see if I know how to do that. Just a sec. Okay. Is this better?
Alex, you're our screen guy. Perfect.
Let me know. I can zoom in even more if it's required.
Great. We'll give another minute for everyone to be set, and then we'll continue.
Yeah. So, and if you're just joining in, then we're doing an observability workshop, and we're building an Express application with AWS Lambda and Express. We've just initialized an empty project and installed our dependencies, which are Express and Got. Express is the HTTP server, and Got is the HTTP client. And the next step would be to actually code the application.
Okay, let's hit another poll, see that everyone's ready.
Sorry, Karen? Oh, okay. You're restarting the poll. Cool. So looks like almost everyone is ready. Karen, I think we can start moving on.
Go ahead.
Okay. So our next step would be to actually code the application. Now, again, we're building a relatively simple Express application. So we're going to do it all in one file. So go ahead and open a new file in this directory. And again, in this directory, you should have now the package.json, the package load, and the node modules directory. And you can go ahead and create a new file called f.js, which will contain our actual application. So what we'll be doing is we'll start out by importing our libraries and then defining the cons of the APIs that we're going to be using. So first, we're going to require Express. And excuse me for using common JS syntax, but I'm just old school like that. You feel more than welcome to use ES6 or whatever you prefer. And we're going to go ahead and require got. And then we're going to define the APIs that we'll be working on. And I'm going to copy paste that just so I won't make any typos. So you'll excuse me. But these are the same APIs that Karen sent earlier.
Gal, can you please zoom in even more to your screen so people can really take a look?
Yeah, no problem. I think this should be good, right?
Seems good to me.
Okay, so we have our libraries we're going to use, and we have our URLs that we're going to use, or at least the base URLs that we're going to use. And now we're going to code 3 helper functions that will make the API request for us. Because remember, our server has to get a city as a parameter and then make 3 API requests in parallel. So we're going to write 3 functions, each making an API request to the correct API that return a promise that resolves with the response of the API. So let's go ahead and do that. Sorry. So our first function would be the getWeather function. Now the getWeather function gets a city. And given this city, it makes the correct request. So the first thing we have to do is build the full URL, right? Because we have only the base URL and we want to make the request to the correct city in the weather API. So what we're going to do is we're going to combine the weather API base URL with the city that we want to request. This is the first step. Now we actually have to make the request, and got makes it easy for us to do that. So we can just return, let's start with the actual call and then we'll just return it. We can call got with the URL, which will make a get to the URL. We will return the convert response to a JSON. And if anything bad happens, we can just ignore it for now. But feel free to add a log, for example, if that's better for you. And we just have to remember to return this, because what we have in this expression is basically a promise. Got returns the promise, converting it to JSON returns the promise, and catching also returns the promise. And this promise will resolve with the response of the get HTTP request, and we can use that response to return it to the user. So here we have our first function. Now, our next function is the get news function, which is very, very similar. The only difference is that it has to make the request to the news API. So we have the get news function. And instead of the weather API, we're going to be making a request to the news API. And we're still going to append the city at the end because that's how the API works. And this line remains the same because we still make a request to the URL, wait and get a promise back that will resolve with the HTTP response. Last, we are going to write the facts API function, which will call get fact for today. Now, this function is a bit different because this function doesn't get the city as a parameter, but it has to use the current date to make the correct API request to the facts API and return the response. So what we'll be doing is we'll be using Node's built-in date object to get the current day and the current month. So we'll just go ahead and do that. We'll do const d equal new date, and then we'll get the month via d.getMonth. That's an API of the date object, but we have to add one because it's zero-based, unlike us normal people, which are using months as a one-based system. And then we have to also get the day. Now, the day is, we can simply get it by using d.getDate. Date. Now that we have the month and the day, we can again build the correct URL and make the request. So what we'll be doing now is we'll be building the URL with the same mechanism, basically taking the base URL of the facts API and then attaching the month and the day. Now that we have the URL, all that's left is to make the request. My computer is moving a bit slow because of the screen share and everything, so excuse me for that. But we'll be returning an GOT request on the URL. This time we'll be converting it to text and not to JSON because the response of the facts API is simply a text. The request as the response, the fact as a text. There's no JSON involved. And again, if we get an error, we're going to just ignore it because we're being very responsible in this workshop. Okay, I see that I'm very inconsistent with my comma usage. So let me just fix that. Okay, so before we launch the actual application, we've just finished the helper functions. We've just finished defining the const and the helpers that we're going to be using. I think this is a good time to see that everyone's up to speed, everyone have their function ready. So let's launch a quick poll to see that everyone is still up to speed. It's fine if it's not tested yet, and it's fine if we're gonna have bugs. Once we will create the Express app and connect it to these functions, we're going to have some time to test it and ask questions. But let's everyone make sure that you have those functions laid out. And Karen, let's launch a poll to see that we're making progress. By the way, since I'm typing this, if anyone spots typo, feel free to let me know. Because I'm bound to make one eventually. It'll probably mess up something very, very important.
Okay, I think we'll give it another minute for those who are not ready yet.
No problem. sure why my computer is moving so slowly. Let's see if I can fix that in the meantime.
Okay, I'm setting another poll to see where everyone's at.
Yeah, sorry for switching the screen. So let's give it maybe, because I switched the screen to another view. So maybe let's give it just another minute so everyone can see the full code here.
Sure.
Okay, so I think we're good to relaunch another poll and see if everyone is up to speed.
I think you're good to go.
Okay. So let's carry on. So the next thing that we're going to do is actually build the Express app. So what we're going to do is first create the actual Express app. Now, in order to do that, what you have to do is define a variable and call Express like that. Now, calling Express like that will put into the app the Express object that represents an HTTP server. Now, this object exposes an API called GET, which helps you to configure GET routes for your HTTP server. What we're going to do is we're going to call app-get, and app-get gets two parameters, the route and the handler for the route, at least for the version that we'll be using now. So what we're going to do is for the route called digest and city, basically our application, in order to reach our application, we'll have to make a GET request to /digest/city. And when we get this request, we're going to be performing a function. We're going to be calling a function that does the following. And what I'm doing here is I'm defining an anonymous function, anonymous error function, as the second parameter for the app.get function. So we have the app.get, which gets two parameters. First is a string, and second is an asynchronous function. And what this handler does is first, we're going to be getting the city that the user got the requested data on. We're going to extract the city from the request parameters like so. So we're going to define city, and city is going to get the request. Note that the handler gets two parameters, the request and the response object, request.params.city. And now that we have the city, we are going to make 3 parallel requests using the helper function that we defined earlier. Now, how can we make this parallel request? It's very easy to do using promise.all. So promise.all is a utility that helps you combine, let's say, combine promises. You're waiting for all the promises to resolve, or at least one of them to reject. And when that happens, you get the response of all of those that resolved, or the error from the one that rejects, or null for if any one of them rejected. So we're going to call promise.all, and promise.all get a list of promises to concatenate. So the list that we're going to give to promise.all will contain calls to all the different helper functions that returns promises. So the first would be get weather on the city. The second would be get news of the city. And the third would be get fact for today. Okay. Now all that's left to do is to actually look at the response of the result of promise.all. Because right now we're just making another promise, but we're not doing anything with it. So first, we want to await for this promise to resolve before we return the response to the user. But we also want to collect the data from the responses. Now, promise.all return an array of the responses with the order that's the same as the array given to promise.all as an argument. So we're going to perform an array destruction to get the responses that we want. So what we'll do here is we're going to define 3 variables using an array destruction: weather, news, and fact, which will get a result of the promise.all operation. Now, at this point, when this function executes, we have the response from the 3 different APIs that we invoked. We invoked them in parallel, waited for all of them to return a response, and then we have those responses on our hand. Now, all that's left to do is return to the user the response as a JSON. And that's very easy to do using the response object of Express. So what we'll be doing is we're calling the response.json, which basically helps us return a JSON to the user. And the JSON that we'll be passing will be made out of the weather, the news, and the fact. So the response that the user will be getting is a JSON document with 3 top-level items: the weather, and then a JSON document describing the weather, a news, and then a JSON document describing the news, and fact, which is a string that is the fact that is relevant for today. So that's our main route. Now, if the user makes a request to any other route, we just want to return 404. So we'll use a nifty little Express trick called appUse anything. So the first parameter is no matter what you get, that's not digest city because it's more specific. What you want to do is, given the request and the response, just send the response status of 404, which means not found, because any other page isn't available on our application. And we're going to send just a string not found, just because we're not building a fancy UI app. So a string will be enough here. Okay. The last thing we have to do is actually run our Express app. We have defined our Express object, and now we have to run it using app.listen. So what we'll do is we run app.listen, and we're going to be listening on port 3000, and we're just going to do a nice callback function to let us know that it's running. So when the app started listening, we're going to do console log app is running. Okay, we should be good to go. So if everything is going correctly, and I'll be splitting my screens so you can still be you'll still be able to see the code and also see the result of what we've just done here. But if we've coded everything correctly, what should happen is we should be able to run our app.js file, and it will start an HTTP server that makes the request to the third-party APIs and returns the responses. And we can easily test that by just typing node app.js, which will execute it using Node. And we can see that we got a print that the app is running. And now we can just easily test it in our browser. So we're going to go to localhost because we're running locally on port 3000. Now, if we don't give any path parameters, then we expect to get a not found response. Let's see that we get that. Yeah, we got a not found response, which means that at least that our application is running. Now let's see that it's actually functioning, but at least the app is running. The next part would be to actually go to the correct route. And if there was someone here from Amsterdam, right? So let's try to see what the weather in Amsterdam looks like. And I hope I'm spelling it right. And so we see that we got a response. So we see that the response contained the weather, and there's a bunch of JSON document that describes the weather. And we have the news here, but there is no news in regards that are relevant to Amsterdam, probably because I did a typo or didn't use a capital letter. Let me just try to see if a capital letter saves me here. But if it's a typo, then my deepest, not regrets, my deepest
apologies.
Apologies, exactly, to whoever is here from Amsterdam, and I brutally misspelled his city's name. And last but not least is the fact, which is February 24th is the day in 3003, the Battle of Roslin, the first war of Scottish independence. So if anyone's here from Scotland, congratulations and have a happy holiday, I think. Okay, so we see that our application is working, and the next step would be to actually deploy that to the cloud. But before we do that, I think this is a good time to pause and make sure that everyone's up to speed. Everyone's got their application running locally. So Karen, I think we can give it a minute and then launch a poll to see that everyone has executed their application locally, got the correct responses from the server. If something is not working, feel free to ask on Discord, ask on the chat. We're a relatively intimate crowd, so we can be very, very specific with our help. In the meantime, I'm gonna search. Oh, I don't have to search how Amsterdam is spelled. I have it in the chat. Amsterdam. Yeah, I think I got it right. Maybe there's just no news. I guess boring day.
No news is good news, in your opinion?
Yeah, I guess. I guess. No news is good news. Let's kill the app here because my computer can't take it anyway.
Okay, let's give it another minute because I see some people are not ready yet. I'm going to end the poll and we'll
no
it
worries.
again in a few.
Yeah, and this step can take a while. So no worries if stuff doesn't work on the first time and you have like a quick tweaks that you have to do in order to get it working. It's completely normal. While we wait, I have a question for the audience regarding the speed of my computer. So maybe we can have another poll for it later, Karen. Basically, my computer is very old and I have to replace it. but there are a lot of fun stickers on it, and there are no physical events now. And the question is, is it fine? Do you think it's fine to give up all the stickers on my computer in exchange for a computer that is working, or are the stickers on the computer way more important than the computer being functional? My opinion is the stickers are way more important.
I think you should do a Hall of Fame of your old computers and their stickers. Gal Jimisola asks if you can show your code, please.
Yeah, sorry, there was a glitch in the... Can you see it now? If not, let me know.
I'm going to relaunch the poll in just a minute.
I think you can give it another minute, but because I just unminimized the code. Also, if you're not familiar with it, what I'm using to split my terminal into two terminals and then close the split is called Tmux, T-M-U-X, which is a very, very cool tool in your disposal when you're using the CLI. So I highly recommend to read about it later. I know there are a bunch of alternatives which should be better, like I forgot the name. Maybe if someone has a Tmux alternative, feel free to suggest it. But I really like Tmux and I really recommend it to everybody. Oh, that's actually a good idea about the battery, because I think the main problem with my computer is the battery. So maybe I just do a battery replacement and stick with the old one, because there's just a bunch of them and I can't let them go. Okay, so putting the thin film that's a good idea. Someone DM'd me that for the new computer you can actually like put a large glass sticker and then stick your stickers on top of that, and then you can just peel it to the next one. That's cool. Jim Sola, regarding the news API, it's very, very deep. Yeah, it's iTerm, right? Yeah. Oh, really? Because I'm using Tmux in iTerm, so I should really check that out. Jimmy Sola, regarding the news API, that's okay. That's what it returns if there's just no news found for the city. You can try making a request to /digest. I'm sending it in the Discord chat /digest/Paris with a capital T. Oh, the Discord chat really doesn't like slashes, but if you do that, it'll probably return a response. Yeah. So it's just a matter of are there actual news there, and it's not like a very sophisticated news API. It's just for the purpose of the demonstration. So sometimes, even if there are news regarding the city, you won't be getting any.
Okay, should we poll again just to make sure?
Yeah, I think we can poll again. Buying the stickers online, I don't know. It's kind of vendor stickers from different events, like of SkylaDB and Serverless Framework, and like stuff that they don't make anymore.
It's like badges of honor, right?
Yeah, yeah.
Okay, I think we're good to go.
Yeah. Okay. So Cool. Perfect. So we're done with coding, with the coding the application part, but now we have to deploy our application. Now, in order to deploy our application to AWS Lambda, we're going to be using a tool called the Serverless Framework. I hope that some of you are familiar with it, but if they're not, that's totally fine. The Serverless Framework is basically an open source CLI tools that helps you deploy serverless functions, whether it's to AWS Lambda, Google Cloud Functions, Microsoft, I think they call it Azure Functions, IBM Cloud Functions, et cetera, we're going to be using AWS Lambda, but later you can deploy to whatever you'd like. In order to install the serverless framework, all you have to do is basically, then we're going to be installing it globally because it's a CLI tool, but you can run npm install serverless. And I think I probably have it installed. So for me, it'll take a very short time, but if you don't have installed, then it's a relatively big CLI package. So it might take a while. So I think I'll run this install, I'll run the next install that we need, and then we can pull on that. Look at that, takes a little while for me too. By the way, if I'm getting anyone's name wrong, I'm terribly sorry, and feel free to publicly or privately correct me on how to say that. Try to close the Discord. Maybe this one is what's eating my computer's memory. And we'll launch it. While we wait for serverless to install, the next package that we're going to be installing is called Serverless HTTP. This package basically knows how to wrap an Express application into an AWS Lambda deployment. Now, what's the challenge about that? AWS Lambda deployment isn't like a regular container deployment. Your function endpoint has to follow a very specific standard. It basically has to be an endpoint. You have to specify in your file the function name that gets 2 parameters or 3 parameters as a trigger, the event, the context, and the callback. Newer versions have it set up a bit differently. But the concept is that our Express application isn't like that. We're just running app.listen, and then we're just listening. But with serverless functions, you're not just listening for events, but your code is actually only being triggered when an event is being identified by another AWS service. In this case, we're going to be using an API gateway. So the serverless framework will not only set up the Lambda function, but also the API gateway that triggers this Lambda function. So we don't have to have a server that is set up and waiting for a request, but only a piece of code inside the Lambda function that can handle a request that is coming from the API gateway. So what we're going to be doing is we're going to wrap our Express application with a tool called Serverless HTTP that does exactly that. it takes an Express application and converts it into an object that can be exposed to AWS Lambda to work with. So our next command is going to be npm install, you guessed it, serverless HTTP. Okay, this one went way quicker. So I think let's have a quick poll to just make sure that everyone has serverless and serverless HTTP installed, because I know the serverless installation can take a little bit of time, and then we'll keep going. I see everyone here is connected to fiber, and only me running on Wi-Fi.
Okay, let's give it another minute for the sake of those who are yet to be ready.
No problem.
I'm going to repoll in just a minute and check that everyone is ready.
Perfect.
Awesome. I think we're pretty much ready to go.
Okay. I locked my roommate out. Okay, so we have installed serverless, we've installed serverless HTTP. Now all we have to do is create our serverless.yaml file, which describes our deployment to AWS Lambda, and make a little tweak to our Express application so it will be wrapped with the serverless HTTP wrapper. So let's start with that because it's a bit simpler. Now, all we have to do here is require SLS HTTP. So let's go ahead and do that. It's require serverless HTTP. And then instead of launching our application, I'm going to comment that out. You can just delete that. We're going to export from this model, from this node model, from this JS file. We're going to export via model exports a member called handler. Let's see that I didn't get a typo here, model.exports.handler. And the handler is going to be SLS HTTP on the app. Now, what SLS HTTP on the app returns is a function that is compliant with the AWS Lambda API. And when invoked, it invokes the correct route of the Express application, given the route that the API gateway was called with. So these are the two changes that you have to make. One is adding the required to the SLS HTTP. And the second is exporting the handler member, which is just wrapping the app with an SLS HTTP. I will be at the end, after I write the serverless.yaml file, I will be showing both side by side, so you can actually have a look at both. But let's dig into what a Lambda deployment looks like. So we're going to create a file called serverless.yaml, which is the file that serverless automatically picks up in order to do a deployment. And this file has a bunch of parameters, and I'm gonna go ahead and explain each one of them. The first is basically the service name. We're going to tell the serverless framework what to name, what prefix to name all of our Lambda functions in the service. And we're going to simply use daily digest, because that's our application, right? It's daily digest. Then there's the provider section. Since serverless can work with a bunch of different providers, you have to be very specific on what you're going to use. So for example, our provider name, the cloud vendor, is AWS. We're running on AWS Lambda, not on Google Cloud Functions. Next are definitions that are specific to the provider that we just used, AWS. So the runtime of the Lambda is going to be Node.js 12, just because that's what I'm used to work with. You can easily use Node.js 14 as well, because AWS Lambda supports that too. The stage is going to be dev, just because we're developing. The region, we're going to be deploying to US East 1, but again, I'm going to be deploying to US East 1. You can deploy to whatever region you used to work with. AWS has a bunch of regions in the US and the EU, in Australia, whatever. And then we're going to define our functions, which is the core part of our deployment. So we're going to have exactly one function, which is our app, because again, we package an entire application into one Lambda function. And the handler of the function is exactly the handler that we exported. So on the app file, we have a member that is exported called handler, and this will be the handler for our function. So here, the orange handler is the name of the member that Serverless Framework expects to get the handler in, and our handler happens to reside in app.handler. So this is what we're going to be doing. Note to not do anything like that. You want to go ahead and just write app.handler. It knows the root path automatically. And then we're going to define what events trigger our function, okay? So basically, we want to be triggered on HTTP events because we want to be triggered on an API gateway. When an API gateway gets a request, we want to be triggered and our Lambda will be invoked. So we will be triggered on an HTTP event where the path is / and on any method, doesn't matter if it's get, post, put, whatever, will be invoked, and we will be enabling CORS. Now, we don't want to do it only on /, we want to do it on /digest /city, for example. So there's a nifty syntax for that, which basically we're going to be setting another event, but it's on the same API gateway, and it's on the same, triggering the same Lambda function, but we're going to say, and I'm going to just ident that in. We're going to be saying that if the path is / whatever, and the method is, again, any method, we're still going to be triggering this Lambda function. And again, we're going to be enabling CORS in this one too. Now, what I'm going to be doing is I'm going to run the deployment, since it takes a little time. And then I'll go back and share the code again so you can all look at it, and we're going to pause and make sure that everyone got their Lambda deployed. So I'm going to go down here. I'll just make sure that it's saved. And I'm going to run serverless deploy. Now, actually, now that I think of it, you may have to configure your serverless first if you don't have the AWS CLI already configured on your computer. So if anyone is experiencing any trouble with that, let us know in the chat or in the Discord.
Discord.
Discord, forgot the name. And we can totally help with that. But for now, I just run serverless deploy. And we will see that the deployment begins. And we'll run that in the background, and I'll share the code so you can look at it yourself. You just see that it's starting. Okay, so it is starting, and we're going to be zooming in on the code again. And again, here, just requiring the SLS HTTP, and then on the bottom, using it. And thanks for sharing the link on configuring the CLI. That's super, super helpful. So if anyone's don't have it configured, feel free to take the time, configure the CLI, and let me know if you need any assistance.
Gal, in the meantime, we have a question in Discord.
Yeah. App in app.handler, is that a reference to app file or something? Yeah. So yeah, that's a very good question. So it's a reference to the file. If you call your entry point index.js, then it should be index.handler and not app.handler, because app is not exported from the app.js model. The only thing that is exported is the handler. There's no dark magic here. App is the file, and if you use the different file name that you should use instead of app, the different file name that you use, for example, index. And if you exported not as handler, but as something else, then you should replace the handler here. So use app.something else or whatever name that you gave your export. Yeah, very good question.
Now we have another question. What if your file is a subdir, say SRE files?
Yeah, so in this case, you can use the serverless framework by saying, let's say, app/src dot something. I think it also supports app so it's src/app dot something, but it also supports src dot app dot something. But I'm not entirely sure about the last thing that I said, but the nested files are totally supported. Is it possible to generate this YAML from CI/CD? So that's a very, very good question. Actually, at Epsagon, our entire backend is serverless. We're using Lambda all the time. And what you usually do is basically, you don't have the CI/CD generate this YAML, just like the CI/CD doesn't generate Terraform, for example, but you commit this YAML to your repository, and then the CI/CD calls serverless deploy in order to deploy your application. Does that make sense? So the YAML is committed into your repository because it's the configuration of your deployment, and then the CI/CD uses this YAML in order to deploy. Okay, Karen, I think we can launch a poll here to make sure that everyone got the code down.
Here we go.
You know what? Actually, instead of launching the poll, let's just show everyone how to test that their code is correctly working, and then we'll launch another poll. But anyway, I see you already launched, so that's okay. To check that your code is working, basically you can see now my deployment part. So I've run serverless deploy. I have a bunch of output, and then I can see the information of the deployed service. And this is the endpoint for the API gateway that got deployed. So hopefully, if I'll go into this path, sorry, what I should be getting is a response of not found. So Curious DM'd me saying that it requires AWS configuration. Do you need a hand with that, or you're just taking a bit of time? Because you can configure the AWS, that's totally fine. Anyway, so I'll be giving a bit of time just after I run this and make sure that it works. Yeah, okay. So again, if I'll be making this request, I expect to get not found. And it looks like that was successful. And if I go to /digest/London, I expect to get a response on London. And here we have it, a fully functional API that's being deployed and is publicly accessible very, very easily. So just making sure that everyone got to that part, and everyone is, now you can, if you're still configuring your CLI, that's fine. Feel free to configure. We have time for that. And also deploy your application. That might take a while because depending where you are located in the world, deployment can take a bit of time. And then we'll be launching a poll in about 1 minute or 2 minutes to see how's everyone doing and if everyone's already done with the configuration, or do we still have to wait on a few people? And that is it. My endpoint choice execute API dot API dot EU north1.amazon.com. Let's see. So can you share the code that you use, the serverless YAML? So I wonder what the endpoint join does. Oh, okay, got it. So note that, yeah, that was a mistake. So note that on the first HTTP event, there's a /dev that was an autocomplete from my editor. So basically, this is actually an interesting case. Everyone can look at the chat. So basically, what we configured here is if you go to /dev, then you get a response, and if you go to /anything, that you get, both of them will trigger the function. But the root / doesn't work since we didn't configure it. Yeah, so you can just redeploy, just remove the / and redeploy, and the serverless framework will take care of it. It will remove the old configuration, remove the /dev, and add the simple /, and then you should be able to get a response on just / getting a not found, the 404 not found.
We also have a Discord question, a newbie question.
Oh.
We can use every NPM library on Lambda serverless function, i.e. Redis, Bull, etc.
Very, very good question. The general answer is yes. You can use any library because its serverless framework just packages it up. And in the deployment that it brings up to the AWS Lambda, it just packages the node modules directory. And AWS Lambda is basically just a Linux environment that you can run anything in. The only pitfall is that sometimes there are dependencies that are not native Node or JavaScript code, but are compiled C code that only works on certain environments. And if they don't work on Linux, or if they have some special requirements that doesn't work on the exact Linux framework that Amazon AWS Lambda is using, then it's going to be problematic. But in the general case, you can package anything that you want. And Jimmy Sola, no worries. You can take any time that you need. That's totally fine. Just redeploy the application, and it should work.
Okay, Jimmy Sola, you made me do this. Here's another poll coming.
God, how I wish I had Fiber here. I'm not sure that we have it.
I'm pretty sure we have
Fiber. No, we have Fiber in Israel, but I don't have it in the. We have it on certain blocks.
Areas,
not all the not all the buildings got it yet. So I'm not sure that my building has it.
I hope we're not popping any tech bubbles about Israel here.
No, I mean I live in the suburbs. Central Israel is fine. That I know when I was younger and I went on like a trip with like from all around the world, then you'd had some people thinking that Israel is a tech nation, and then some people that figure that we go to school on camels. So there's like a wide variety of what you conceive Israel to be, but it's pretty normal.
To be clear, we're not riding camels here.
Yeah, we're not riding camels.
Okay, we have another Discord channel.
I wish we would.
A follow-up question. Assuming I deploy 2 serverless functions, each has a different IP DNS address.
Yeah, so that's a very good question. And I see that there was another question before that. So where do we go to see our serverless on AWS? It doesn't show on AWS AppSync. So you should go to AWS Lambda, and I will show that in a second. Just the AWS Lambda page. Maybe I can, Karen can write that down, just like LAMBDA. And the follow-up questions. So if you, let's take another step back. Basically, a serverless function doesn't have an IP or a DNS. A serverless function is, it can have them like an internal IP, and it goes via a NAT gateway outside, and you can make HTTP request, but it's not the serverless function, the Lambda function, that has an IP address. It's the API gateway. And here, if you can attach multiple functions to the same API gateway, but you can attach multiple functions to different API gateways. And if you do that, so each API gateway can get a different domain or an IP, but each API gateway has one base DNS that it gets set up with. You can configure via Route 53 additional DNSs to point to this API gateway, because usually you don't want this random generated name, but you want your company name to be the API endpoint. And I think regarding IP, I'm not even sure that API gateway has a static IP. I think it can be changing over time. But for DNS configuration, that's the general answer, that an API gateway has a base DNS, and I think you can, of course, you can add additional DNS that points to it. And it can be connected to a bunch of Lambda functions, but you can also connect a bunch of API gateways to a bunch of Lambda functions, or a bunch of API gateways to the same Lambda function. And I think Nahul, you raised the hand, but I'm not sure.
Yeah, I'm gonna unmute you, Noel. I'm sorry if I'm mispronouncing your name, so feel free to ask your question. You're now unmuted.
You need to buy an iCamel. Nope, I think maybe it's just an accidental hand raise. Okay, so I think we can. Thanks for. I'm really glad you like the answer. I think we can maybe launch the poll again and see if everyone's ready.
Sure. Okay, seems pretty unanimous.
Cool. So I think we'll be moving along. And so first of all, congratulations. We have built our applications. We have deployed our application. We have seen it working. Now, the only question is, what is going on? Oh, sorry, someone's getting, is user, Alex saying user is not authorized to perform CloudFormation, describe stacks on resource. Is there any chance, Alex, that you're using an AWS account that you don't have full access to? Like that is a company AWS account or something like that, and you're not a root user? If that's an account that you fully control, then when you configure the AWS CLI, you should add to the or the role that you already configured the AWS CLI with. You can just add permissions, administrator permissions via the IAM. I can just show it real quick, just so you have a sense of what to do later. Let's sign into the console. So if you go to the IAM service, then under users, since this is my dev account and there's basically one user, you can see that I added into my user permission that is called administrator access, which basically gives me the ability to do anything I want with this AWS account. And this is the user that I configured the AWS CLI with. So this is how I have the permission to do that. Yeah, that's a good point. So the user management is global, but make sure that if you have regional permissions set up in your account, then make sure that you're deploying to the correct region that you have the permission to deploy to. But anyway, since we're gonna be having a lot of wait steps in the next part, so I'm just gonna keep going, and it'll be easy for you to catch up.
Gal, just before that, we have another Discord question. What's the case if my function is up and running but doesn't show on the Lambda dashboard on AWS?
So that's probably a region problem. So remember, I deployed to US East 1, but if you deploy to a different region, that's fine. So let's have a quick look on how the Lambda dashboard should look. I'll be going into the Lambda dashboard, and note that I have to be on the right region because Lambda is the regional service, and you deploy and you deploy the Lambda to the specific region. So since I'm on US East 1, I'm going to be able to see my function and of course, inspect the details of it. Cool. So, okay, so we have the application set up and we have it deployed and we've built everything and we're very, very happy because our application is working. But now we want to see what is happening in our production environment. And when we have one Lambda function that can be relatively easy, not so easy, because we can still find the relevant logs, et cetera, et cetera. But the more this function gets invoked, the more log streams and log groups that we'll have. And troubleshooting it, your code size is 37.5 million compared to, I guess maybe you have, maybe you installed serverless without minus G. So you bundled the serverless CLI together with the deployment, but that's totally fine. I mean, it's just a dev dependency. So that's my guess, but 37.5 shouldn't matter as long as the application is working. You're on the right track. Bundling dev dependencies for a dev project is totally acceptable. Okay. So again, if I want to look at the, I can see if I want to monitor my application via AWS, for example, then I can see the metrics for the specific function, but I can't see the whole context. And I can, for example, jump to the logs, and you can see that. No disrespect to AWS, I love AWS Lambda, but this can be a bit tedious. And what I want to show you is how you can use Epsagon to easily troubleshoot your application. So what we're going to do, I'm going to just skip ahead because I don't want to wait for CloudWatch to load on my very, very, very slow computer. So I invite all of you to sign into app.epsagon.com. And what we're going to do here is we're going to create a user, onboard to Epsagon, connect to AWS environment, and send your first trace. And we're going to explore the environment a bit and then do a very, very cool treasure hunt on the environment. And I really think it's very, very cool. Okay, so note that if when I sign in, it automatically takes me to the login page. If you want to sign up, you either can just log in with Google or log in with GitHub. That's definitely the recommended way. If you have a Google or a GitHub account, just use that, log in. That's super easy. If not, I don't have one because I've already used mine up for my real Epsagon application. Then what I'm going to do is I can just create any mail that I want, preferably your mail, but right now I'm just going to do an example. Test.com, and I will just start my free trial. Do not save that. Okay, so we're gonna take the first and the second step here because the second step is a bit longer, and then we're gonna have a poll to make sure that everyone completed the second step. So the first step is just tell us a bit about yourself. Second step is integrating your AWS environment. And the third step is tracing your application. So I'm gonna say that my name is Gal Bashan because that's actually my name and my company is Epsagon. And I do not want my data to be stored on Europe, and I'm using Lambda. So this is what I set up here, and then I hit next. And now I'm going to be integrating my AWS environment to Epsagon. Thank you, Drew, but I got this. So I'll be integrating my AWS environment into Epsagon. So Epsagon support, I'll just show you real quick, a bunch of different environments, whether it's Kubernetes, Azure, OpenWhisk. But today we're going to be integrating AWS. And by integrating AWS, what I mean is simply deploying Epsagon CloudFormation into your account, which gives us permission to monitor the data that we need in order to give you observability into your system. So it's a really one-click integration. All you have to do is click integrate AWS. It will take you to your AWS account to deploy the Epsagon CloudFormation. Everything will already be pre-configured. That's just an ID for us to securely connect to your account. So this is my ID, but I don't have anything in my account, so I don't care that you see it, but don't share it with anyone. And then you have to hit accept on that our CloudFormation stacks create resources with custom names. So that's like very common, but something that AWS wants to get a mark on. And then I'm gonna just hit create stack, which will launch the deployment on my stack. And Epsagon will automatically identify that the stack creation is completed and will take me to the next step. So what we're gonna do is I'm going to wait for the CloudFormation stack integration to be completed, for the creation to be completed. Behind the scene, it just gives us a role with some permissions, some read permissions, and also a CloudTree bucket for us to get events of your system. Just some technical stuff that doesn't really matter, but just in case you're wondering. And that's it. Once your environment is connected, this is the screen you should see. And this automatically popped onto the screen. And before I hit next, I'll just wait for everyone to make sure that everyone got their Epsagon account set up. Have any questions? If the integration doesn't work, let me know. So let's wait a minute and then Karen launch a poll to see if everyone got it going. Ooh, Francis got it.
Awesome. I'll just make a note here that in order to participate in our award-winning treasure hunt, you have to have an Epsagon account.
Yeah, it's on the platform. The treasure hunt's on the platform. It's kind of a cool game. The AWS Access Key ID needs a subscription for the service. Where do you get that from? Is that an error on the CloudFormation console? Maybe you can share a screenshot in the Discord. Oh, on serverless deploy. Can you share the full output? Oh, so Kyriakos, did you set up the AWS CLI on your computer? Yes. Okay. Let's have a quick look. In the meantime, if you can attach in the Discord like the log of the deployment. Oh, and is your and Kyriakos, is your did AWS confirm your I think they need to confirm your credit card number to use the Lambda service.
I'll check out Discord. I see that Kyriakos shared.
Yeah. So let's see on the. And I can also see that there is a validation error. Can you share the serverless.yaml file that you used on the Discord as well? Not. Yeah, if you create a new user, that should be fine. I think you haven't registered your credit card, so I think that might be the problem. There might be another problem with the serverless YAML. If you can share the configuration, it may resolve it. But I think that the problem is that AWS hasn't verified your credit card yet. So there's some resources like Lambda that you can't use. But share your serverless YAML file and let's see if that is indeed the case, or maybe there's another problem there.
In the meantime, I'm gonna check where everyone's at.
Alex got an access denied on S3 create bucket. Alex, did you configure your user as an admin user on the AWS console? Because it seems like this may be the problem, that the user that is configured with the AWS CLI doesn't have enough permissions, for example, to create an S3 bucket. If it will be an administrator, then this should be resolved. Can you share? I see that you're saying that it's an admin, and I can see the serverless. Let's have a look at the serverless YAML first. And by admin, that means that you attach the administrator access policy, right? Okay, so sorry if I'm misspelling that. Kyriakos. So there is a missing indentation for path, method, and cores on both HTTP triggers has to be indented in 2 spaces because this put path and HTTP on the same level instead of path being a child of HTTP and method being a child of HTTP and cores being a child of HTTP in the YAML tree. But I'm not sure this will resolve the issue. I still think that it might be a problem with making sure that you have like AWS has validated your subscription, but you can give it a go. Just ident it as such. Let me show you that. Basically, add 2 spaces here, 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 and 2 spaces here. And let's see if that resolves the issue. And if not, then it's just a matter of AWS confirming your credit card. I'm sorry, I missed the poll. Where's the poll? So there are a few that are not yet ready.
Okay, I'm going to poll again in just a minute.
Okay. And Alex, I'm going to go again to just show you my IAM configuration so you can see if anything's different there. So note that this user is not only in the admin group, it's actually not in the admin group, but the permission that I attach directly is the administrator access. And make sure that this is the user that is configured on your AWS CLI. You can check it on this file. You can basically see .aws.credentials. And here you have the, see that it's the correct user. And make sure that you actually have an administrator access attached. Okay, and I see, Chris, that the problem is probably with Kurekos, the problem is probably with AWS. So Karen, correct me if I'm wrong, but the workshop is recorded. So you can just—
and it will be available for everyone later.
Yeah, it'll be available, and you can just check it out later and like play along once the AWS account gets worked out.
Okay, Gal, I think you can continue.
Okay, so I'll be carrying on, and the next step is to actually trace the application. Now, when we talked about distributed tracing, we talked about adding annotations to the code of where a request begins, where a request ends, where putting an item into a database begins, where it ends, where an HTTP request begins, where it ends. Epsagon does that automatically for you. It does that so automatically that you actually don't even have to change your code. Epsagon automatically connects itself to your Lambda function using AWS layers and injects the library that automatically captures all of the event that is going in your application. And we have similar solutions for container environments, Kubernetes environments, wherever you're running the deployment. Getting integrated with Epsagon is as simple as either importing one line of code or even checking one box. And this is what I encourage you all to do now. Hit next, check out the box. And if you just want to have a quick look on the different ways to integrate, then here we have all of our supported frameworks in all of our different languages. But I'm going to be showing the auto tracing one. Basically, select the checkbox, hit auto trace, and now Epsagon behind the scene connects to the function, traces it, and if all goes well, all we have to do is invoke our function again. And when Epsagon detects that it received the trace, that it understands what the function is doing, it will let us carry on. So I'm really hoping that nothing will be messed up, but because you know how demos are. But if I invoke my function here again, I should be getting the same response. Yes, I got the same response, but now Epsagon will detect my span once it gets and go through the processing pipeline in our backend. And when it detects it, it will automatically let me know that it detected it and let me sign in into the actual Epsagon application. Okay, so let's have a quick poll to see that everyone got to this stage. And now I'll be showing you a bit around Epsagon just so you'll know the ropes. Then we're gonna do the treasure hunt. And I think that is it. I mean, that's not it. There's probably a lot of more surprises, but that's the general idea.
Okay, we'll give it another minute for those who are not ready yet, but I see that most of you have completed that step.
Okay, let's see. It's still waiting for some reason. So it might take a minute or so, but Sagi, just make sure that you made a request to the API. You can even make another one because sometimes auto instrumentation like takes a minute or two, until we actually inject the layer initially. So you can just go ahead and make another request. Oh, okay. And I'm just making sure that you checked the V on the auto tracing and clicked auto trace. Right, check. Okay. So let's see. Let me see if I can see the problem here real quick. Okay, so I see currently no problems. Let me have another look. Okay. Alex, is that from the deployment part or the message missing authentication token? The deployment part or from the Lambda function? I think it's just a matter of the backend being weird. So is it the same when you change the city? Same for London. Okay, so what you can do is until you connect Epsagon, you can run, just a second.
Gal Jai wrote in Discord, I was having the same problem correcting the serverless YAML, solved it for me.
Yeah, can you share, Alex, the serverless YAML on the Discord? Oh, so Sagi, you do not see our CloudFormation? Maybe you hit skip instead of integrating with Epsagon? Do you see Epsagon CloudFormation deployed? So this serverless, it's integrated. I do see the app on Epsagon. Okay, so just a sec, Sagi. Alex, your serverless YAML looks fine. can you share the actual app.js file just to see that this one's fine as well? And Sagi, if you, you don't see the Lambda function on Epsagon, you mean, right? What, on the table, there's nothing there. That's what you mean? Okay, so Alex, I think what you forgot is to add at the end, or maybe you did and it just didn't make the cut yet. Because either you're, oh, okay. Yeah, okay. So you did. Module exports handler, SLSHP app. Yes, I guess send the Discord, send a screenshot in Discord.
And thanks everyone for your patience. We just want to make sure that everyone is at the same step.
So what you can do, just so we'll get a bit more context, Alex. Sec. So my terminal just froze, but I'll just write it here in the Discord so you can copy it. What you can run is serverless logs -f, meaning that's the function API, and that's for Alex. So Alex, on this context, just note that the app.listen is not commented out, so you should comment that out. But you can redeploy with that and it should be fine. So, and note that I sent the serverless logs -f API command that Alex, you can run and give us the output just so we can see what's the problem there. Okay, and Sagi, I see what you sent here. Can you click the auto trace button on the bottom right corner?
Yeah, okay, I did.
And then in a minute, invoke your function again and see if that does the trick.
I'll try. Also try to go back, to click on the back button on the top left corner and then re-enter the auto tracing and redo the steps, but seems like nothing happens.
Okay, let's give it another go.
Okay.
So Alex, that's a synonym. SLS is just short. It's short for serverless, but you can use both.
Okay, Gal, I'm gonna poll in 30 seconds and then I think we should continue.
Okay, and no worries anyone, because that's basically like the last step. So even if I'll just be talking on a bit on Epsagon now and then we'll have the treasure hunt. So while I talk, you can easily like get everything working. So the fact, Alex, that you don't have API on the services, oh, not API, I meant app, that's my bad, APP, sorry. Yeah, you, Sagi, yeah, definitely try with Node 12. That definitely can be a problem, because I'm not sure that the auto instrumentation supports Node.js 14 yet. We have the SDK instrumentation for that. So you can go ahead and deploy with 12 just so we'll see this is working, and I'll take it back with the engineers on why are the problem on Node.js for the environment. But anyway, even if auto tracing is not working, you can still use our SDK. There's a serverless plugin. There's many easy ways to instrument that. Doesn't require you to change your code. So after you click auto trace with the function ticked, you should invoke your function by going into this URL again. And then the screen should, after a minute or so, change to this screen, to the welcome aboard screen. Sorry. Okay, so anyway, I'll be moving forward to just showcase Epsagon. You can still keep on asking me questions during and keep on making it work. And no worries, because right now I won't be making any configuration. I'll just be showcasing the product. So when I hit here, view trace, it's going to take me to the trace that I sent. Now, what is a trace? A trace is basically the flow of data within your application. And this is a very, after we click on the trace. Okay, so OG, I think you have the same problem as less G3. If you deployed using Node 14, try to change to Node 12 because it seems to have resolved the issue for Sagi. And you can maybe just make a few more invocations and give it a little while. Node 12 here. Okay, so I would go in again, hit auto trace just to make sure that it's really traced. And by the way, if you want to make sure that the Lambda is indeed traced, you can go to, because what we do is we add a Lambda layer. So what you can do is go to the Lambda management console. And into the function. And see that there's a layer added. You see that there's one here. Yeah, if the function is auto traced, then you should have one here. So in Epsagon, basically, what you see here is the trace, right? Because we have an HTTP request that is made to /proxy, but it's not really /proxy, right? That's actually, and this is all the data that we automatically correct. That's /dev/digest/London, and then it's invoking a Lambda function. And we can immediately see the response of the Lambda function, and we can see actually the logs of the Lambda. Instead of shifting to a bunch of logs and having to work really hard when we haven't requested, we know that we want to troubleshoot to find the logs of, we can just click here, immediately get to the logs of the application. Now, this is a relatively simple application, and I'll be showing you the screen that I jumped out of in a sec, but this application makes 3 API calls to 3 different APIs, and we can see them here. Now, if these were our APIs and we were making another Lambda handler that is our own behind one of these APIs, then Epsagon would connect the dots for you so you can see the entire flow throughout your application. Since our use case is relatively simple, then we only see one compute unit. But again, if your flow has several compute units, which I guess most of you have, then that would definitely all show in one place. And we collect a lot of data on the different operations that you take, so you can take advantage of that. For example, in the weather API, we collect the request headers, the request body, and the response headers. And the response body, sorry. So for example, I can see that in London, there are clouds and the visibility is 10,000 and other figures that I don't know because I really don't understand weather, but you get the idea. And for example, what I can do is I can not only see the payload, but I can actually index it so I can search it later. And I'll be showing you the search capabilities in a second. But for now, what I'll do, for example, is I'll select the HTTP response body, and I can actually index nested JSON. Clouds, no, let's index the visibility. Just so we'll have it. And maybe let's also index the HTTP, no, let's index on API gateway. On our triggering API gateway, the field that is the actual request that's made, right? Because I want to be able to distinguish different requests. So let's index the path. So I can index the actual path, path on the request context. And I can see that it's request context because here it says request context and here it says path. And this is what I want to index. And I'll just go ahead and index that. And again, I can see this data on anything that my function did. For example, I can see the HTTP request headers. I can see the HTTP response headers. I can basically see everything that is going through my application in one place. And not only I can see it, but I can also search for it. So let's, for example, make some additional requests. One for Chicago, and one for Paris, and one for Madrid, and another one for London, and another one for London. Okay, so what I can do now is I can actually search the payload of my application. And I'm sure you can understand why that's valuable, because while now I'm indexing cities, you can index your user IDs, for example. So if I'll go ahead here and search for the, let me just refresh real quick, because that's loaded the filtering before I refreshed, before I added the index. But adding the index is exactly one thing that you do when you set up the application, and then you're done with it, basically, because your application usually behaves the same. And also Epsagon index a bunch of fields out of the box because we know what's useful. And then we can just search for the correct request path. And we can see all the different requests that were made, and we can see the actual one that we want to look for. If we know that we have an error with specific user or with users making specific types of requests, we can easily pinpoint the request that the user made and again go back to the entire flow of data within the application.
Gal, can you please repeat the add index?
Yeah. So what you can see here is basically each node has different metadata attached to it. So for example, the AWS Lambda has a return value attached to it with the actual entire body that was returned to the user. And the HTTP node here has the metadata of the status code, for example. So in order to index a tag, all you have to do is walk on the node that has the tag that you want to index. Click index tags, and then you have a list here of all the tags that are available to index, both in nested JSON structures and whatever. So for example, I can index the weather, let's say weather main, and then it index, and that's it. Now, what I'll do is make a bunch of more requests. Let's make 2 for London and 1 for Madrid. Yes, the recording will definitely be available for future viewing. And then if I'll go ahead and search, I forgot what we indexed. I think it was weather main. So if I go ahead and go to weather main, then all of these places had clouds, I guess. So we can just search for every city that was requested where the weather was, it had clouds. And note that unlike traditional monitoring, you can actually monitor the business data that's going through your application. How do you open the pop-up window where you set it? Oh, so basically note that right here, there's a little button called index tags. So if I'm on the tag, and right here, there's the index tag button, I can click it and it will open up. About this window, got it. So basically, when you're in the trace search, and there's a table here of the different results that match your search criteria, then if you click on one of them, then the window will just open. You got it? Okay. So note that alongside the graph, you can also look at your transaction in a timeline view. And what I did here is there's a graph on the left, there's two tabs on the left top corner. And instead of graph, I shifted to the timeline. And here I can see that I have one big parent span that represents the API request. And then we can see that for the entire duration, the Lambda was executing. And underneath that, we can actually see how long each different request took. So we can see that we made them actually in parallel. And we can see that the Facts API took much longer than the news and the weather. Now, since we're talking about 50 milliseconds, it's not that bad. But when we're talking on advanced use cases, when you want to perform and solve bottlenecks in your distributed systems, then these tools come in really, really handy. So we saw the trace view, we saw the timeline view. Epsagon also supports your infrastructure and not just your application traces. So I'll be demonstrating with the Lambda Map, but you can see basically a list of all of your different Lambda functions. And then if you want to dive into your function, you can actually see all of the different invocations of it. You can actually see a list of all the invocations, how long it took, how many memory it used. You can immediately jump to the CloudWatch log, to the log of the function. You don't have to shift through a bunch of different logs that because all of the Lambda logs are being written to the same place. And again, if you click on the ID here, you can go back to the trace. And I'll showcase it with functions, but we also support ECS, Kubernetes, AppSync, whatever environment you're running, we probably have it. Now, on top of these metrics and traces, we allow you to create alerts and issues. So I won't go into that a lot because I know you're all eager to get into the treasure hunt and we don't have that much time. Yeah, okay. But our alerting system supports both very simple and very complex alerts. What would happen with sensitive information in the request? I see that the result is actually stored in Epsagon. So Marjay, that's a very good question. And Epsagon has an option for you to either shut off sending metadata at all. So for the functions that handle sensitive functions, you can only pass the metadata and not send the actual payload to Epsagon. But we also have more advanced filtering mechanism, which a lot of our customers use. So you can say, for example, if a JSON item contains token asterisk, then don't send it. And a regex to fit on the JSON keys. Or if it contains password asterisk, then don't send it, et cetera, et cetera. So we have filtering mechanisms on different sensitivity levels depending on the sensitivity of your information. So if it's something that absolutely can be shared under any circumstances, then you can just turn off the metadata for the specific function, container, or Kubernetes pod. And if it's something that you just want to filter out specific fields, then that is also supported. But that's a very good question that we get a lot, because on the one hand, payloads give you a lot of power, but on the other hand, there's a security risks that come with it, and you have to be accountable for that. Also, Epsagon has certificates for HIPAA, ISIO. I don't remember the number, and another third one. Yeah, Karen can probably say all the security certificate. So we can basically serve most companies and store sensitive data for most companies because we uphold the security standards ourselves. And going back to the alerts, so we support both very simple and very complex alerts. So if you want to be alerted on any exception that is being raised, or if you want to be alerted only if 50 Lambda functions cross a certain threshold in a certain amount of time. We also, again, have alerts that are tailored for Kubernetes and not for Lambda, and general alerts on traces that you can set up if there are metric alerts based on the traces. We integrate with a bunch of different vendors so you can get alerts too. If it's not on this list, then we have a bunch more that are new. So you can definitely, you can be sure that Epsagon probably has you covered in your alerting needs. Another thing that I wanted to show and I forgot, and it may come in handy for the treasure hunt, is that you can actually visualize traces data as metrics. And let me show you what I mean by that. You can actually see the trace data over time. Let's look at the last hour, just so we'll have a better granularity. And what I want to show you is that I can perform different aggregation on my trace data to get a lot of insights. And also, again, I can alert based on these metrics. So if I'll group my spans by, for example, the request context path, I can see, for example, what's my most popular city. And the one without a city is basically spans that don't have a city attached to them because they don't describe an HTTP operation. So I can also filter that. I can also only filter where request context.path exists to clear out all the noise. And then I can see that London is the most visited city on my application, and then Madrid, and then I think Chicago is somewhere here with Paris. So this visualization of data, which is not only infrastructure, but actually applicative data, can come in very handy when you troubleshoot issues. And that is it. The service map I'll save for last because we have a cool challenge at the end with it. But I think now would be a good time for questions and then for us to have a little treasure hunt. So if there are any questions, feel free to ask them now. And if not, we'll go right into the treasure hunt.
I think they're ready.
Okay, so let's get started. Basically, we've hidden a secret password within the APIs that your application is using. And yes, Sagi, I will go back to, actually, I'll go back to visualize and see if you have the question on that, and then we'll see the, and then we'll go back to the treasure hunt. Yeah, do you have a question on the visualize section? If you want to enable it, then there's the hide button and the visualize button right here under the trace filters.
Yeah, just that I don't see what you're seeing here. My graph looks a bit different.
Oh, okay. So remember, I'm sorry, just 1 second. Remember that the graph is based on the request that you actually made to the application. So I see a lot of requests to London because I made a lot of requests to London. But if you made requests to a different city, then you will probably see a different city. And again, also note that in order to differentiate them, I set the group by field to be request context.path. And I can group my results by different fields. But if you want to see them broken down, then you have to use the group by field according to which field you want the results to be broken down by. Okay? Cool. So back to the treasure hunt. So we have a password hidden in the application. The first one to find the password that is hidden in the application will win an Epsagon swag box. Now, of course, you wrote the application, so you know there's no password hidden in the code, but the password is hidden within the API responses. Now, that's not an easy challenge, but I think you can all use Epsagon and easily find the solution. I would suggest you, if you want to really get the solution fast, make a lot of requests so you have a lot of data to work with. And remember, the solution is in the API responses, in the headers, in the body, whatever. And you know, X marks the spot. So go ahead, feel free to ask any question. And the first one to post, I prefer you do it in Discord, but if you do it in the Zoom chat, that's also fine. The first one to post the password basically wins. So go. EPSA, so that's close. That's the first step toward the password, but you're Alex VNZ, you're definitely in the correct direction. Maybe send a bunch more requests and see if you can find a bit more data. But that's definitely the first step towards the solution.
That's a major hint. In the meantime, feel free to ask any questions, queries, whatever you have for Gal, and we will make sure to answer and reply everything.
I'll start giving hints in a few more minutes. But
Make
Alex,
them sweat just a bit, okay? Just a bit.
Yeah, but Alex, you're definitely on the right track. Auto trace never complete. So Jimmy Sola, just making sure that you are using Node 12 as a provider and not Node 13. Yes. So can you just try to hit auto trace again? So check the box and then on the right bottom side, click auto trace. You can just even reload the page. It will keep you on the same step. I will look on my end to see if there's permission issues or something like that. Okay, so Leslie, you got Gonji. You're on the right track. So you can see where the password is, but it's not as simple as that. You have to look at a bit more data, a bit more requests, and note that there's some additional Epsagon stuff there. And note that, by the way, what Alex posted and what you posted kind of combines together, right? So maybe that's another hint. So yeah, definitely that's the right path, but that's definitely the right path, but there's still a bunch more that you have to. It's a bit of a longer password than that.
I see that they're getting the hang of it, though.
Okay, Jim Sola, let me have a look.
And I hope that Alex and Sergey are not the only one participating. You're just cracking it.
Okay, so Jimmy Sol, I don't see a problem on our end. Can you try just a different city? I know it probably won't do much difference, but actually you see 0 layers, right? So that is not so well. You reloaded the page, tick and auto traced again. Okay, so if that doesn't work, we can stay a bit later and at the end and see why that didn't work for you. Okay, so I'm gonna go ahead and give a little hint. So you all, like Alex and Leslie, you found the field that is interesting, like the tag that has the part of the password. Okay, so Sagi, you can just refresh the page because once you index something, it only indexes from there on out. So you have to index, send a bunch of requests, and then the Dropbox will have like, Epsagon will know that you have actual data that contains this, this payload, and you can search for it. So for example, so Ultrix, you're on the right path, but almost. Maybe we made the password too long, right, Karen?
I don't think so. We have to make it a bit of a challenge, you know? But you're definitely, ooh, Kyriakos,
okay,
you're very
Kyriakos,
close.
You're almost there, you're almost there.
And
you
also
are,
Alex.
Yeah. Almost.
Oh, okay, now we're getting there.
Now you're just guessing.
Which is a good strategy. I probably would do the same. But yeah, you're really, really close. Let's see who's the one. Oh, who's good? And we have our winner.
Yeah, we have a winner.
If I'm not mistaken, Alex is the winner. Just
look.
Confirm that. Please confirm that.
Yeah, let me just have a look. Yep. So
so we're setting our Epsagon free and we have a winner. So Alex, congratulations, and I'll DM you.
Wait. No, actually it's not Alex, sorry. Actually, oh yeah, Alex. Yeah, Alex got it right. Alex got it right. Yeah, Alex got it right. Sorry.
Yeah, no foul play here. No foul play here.
No, yeah, I think he's also the only one that sent the correct address.
Right.
The correct response so far. So that's
Alex,
safe to
congrats.
say that he won it fair and square. I just want to walk you through the solution real quick and how you can easily do that with Epsagon. So I guess most of you noticed that, of course, the password that is hidden has to be somewhere in the response of the APIs, of different APIs. So it can be either in the response body and the response headers. Since the response body is something that actually is displayed to the user, it will probably be in the headers. And what we can see here is that Epsagon added two hidden headers. One is the Epsagon order, and two is the Epsagon secret. So for example, the Epsagon secret has 4 words, 4 letters, and the order is where it sits in the order. So Gon G is the second part, but if I'll go here on the response headers, I can see that EPSA is the first part. So Epsagon Node Congress 2021. So that's the password. Now I can go trace by trace and try to understand what is the password. But what I can also do is I can index the Epsagon secret part. And now after I've indexed that, I can use Epsagon visualization capabilities in order to understand the password. So I'll just make a bunch of requests. Just so I'll have enough data to work with, because the password is relatively long. And my computer froze. Nice. Okay. And then what I can do is basically group my results based on that field. And what I expect to see is just the, if I visualize the results and group them based on that field, I will just be able to see the password, I hope, clearly. So let's give that a go. So we want to see X Epsagon secret. And what we'll see here is we can easily see Epsagon Node Congress 20. Oh, okay. So the order got a bit messed up here because, you know, it's statistically, but if I'll make a bunch of more requests, then it'll probably be okay. Because it just ordered them from the most frequent to the least frequent. And what we did is we made EPSA the most frequent, then Gon G a bit less frequent, and et cetera, et cetera. And so, yeah, here you see that actually code C got above it. But when you have all of these parts in front of you, it's really easy to see, okay, so the password is Epsagon Node Congress 2021. And that's just one of the little nifty things that you can do with Epsagon to not only monitor your application, but actually get insight into your application and insight into your user behavior. So that was our first contest. We're going to have a small little context for afterwards, but congratulations to our winner. So I just want to sum up before we open the floor again for another session of Q&A, and then just let you know of our offline contest. Basically, when you're talking about getting observability for your system, you need to understand that getting the distributed context is super crucial. And if you want to get it right, you have to be automatic about it, because humans make mistakes, and maintaining tracing code is hard. And in order to get the best experience and understand your environment, you want to automatically capture everything that's going on so you can analyze that later, both for troubleshooting purposes, monitoring purposes, and data insight purposes. You want to be able to support any environment. We showed Lambda, but I guess a lot of you have hybrid environments that mix Lambda, ECS, AppSync, Kubernetes, just plain EC2 servers. There are a bunch of different environments. So you want a solution that supports all of them, and distributed tracing at the application level definitely supports all of them. And you just want to be able to easily quick point the problem. So you want to be alerted when an issue happens, and you want to be able to see from the specific event the entire flow that led up to it. So if I'll give you, that's the best summary I can give you to, if you want to be successful in monitoring your distributed system and your modern system, then you need to have a solution that combines traces, logs, and metrics in a fully automated way. And of course, I recommend Epsagon, but any solution that does that is something that you want to have in your tool belt. So that is almost it. Let's do a quick Q&A and then announce if anyone has any more questions left, and then we'll just announce our latest competition and be done for the day.
Feel free to unmute yourself, or if you feel more comfortable just posting your questions on Discord or in the chat box. In the meantime, we would love to get your feedback on the workshop in order for us to improve and do better next time. So I will be launching this poll right now, but again, feel free to unmute and post your questions, of course.
Feel free to respond truthfully. I close the poll. I don't see the results. I won't be offended.
Yeah, it's truly for us to know where we can improve. And if you have any feedback, feel free to share it with us via DM, chat box, Zoom, Discord, however you'd like.
Okay, so I guess if there are no more questions, if you stuck with us this far, we'll be going to announce our latest competition. And in order to do that, I'll be showing the architecture map in a second. But basically the competition is, now that you're done, and now that you're familiar with Epsagon, next step is to integrate Epsagon into your environment. And actually, you know what, let me quickly show the screen and then you can easily understand what the competition is. The surface map is basically a place for you to see the architecture over time. It's a place for you to immediately see what your production looks like. Now, our production looks relatively simple, but there are a lot of complex environments that looks much more complex than that. And you can see how your application is behaving over time and also how it looks. So it's very useful for performance, bottlenecks, troubleshooting, and monitoring, but also useful just to onboard new members to the team, for example. So you can see what your application looks like, and you can also dive into each and every resource over time. This is all, again, completely automatically generated. You can see, for example, for this Lambda, the average duration, the average success rate, and you can also see the average breakdown of where it's wastes its time. So the architecture view is very, very useful for performance monitoring and optimization for the architects in your company, for the more experienced engineers in your company. Very, very useful. But another thing about the architecture view is that it tends to be very, very beautiful. So our competition is basically for you to integrate Epsagon into your environment and then share on Twitter your architecture screenshot. You can hide the labels. You don't have to, you have an option to hide the labels. You don't have to share the actual resources name with the entire world, but just show your world what your architecture looks like. Tag us, add a hashtag of my Epsagon architecture and tag Epsagon. And the best architecture, the one that looks the most amazing, most complex, not the most complex, but the most elegant, will win an Apple Watch. So this is very, very cool. Let your friends know about it. If you know a friend that has a cool architecture and you want to share, so feel free to share with anyone on your team or any friend anywhere. And again, we will announce the winner on March 10th, and he will win an Apple Watch, which is very cool, Karen, when I'm getting my Apple Watch. Never, yeah, I know. But you can get yours. So integrate your environment with Epsagon. If you're having any problem, reach out to us. We'll help you sort that out. And I really hope that you send us some amazingly beautiful architecture maps because we've seen some very, very beautiful ones in the past, and we would love to see yours. I think that's it. Thank you, everybody. I'll be here if you have any more questions. Karen will also be here. Feel free to reach out afterwards via email, via Twitter, via our website, via our application, just anyway. We would love to help you on board, just answer general cloud questions, general Node questions, general Lambda questions, and we would just love to help. So in any way we can. So I hope you enjoy the workshop. If you have any questions, feel free to ask them now, and have the great rest of the day.
Thank you, everyone. And our Discord channel is still available and open for everyone. You can also share the competition we had with your teammates. So thanks for everyone for joining.